Hey team, Chemistry Coach coming at you with possibly the most important video you can watch in chemistry, right? Loose structures is a big one. I'd put that at number two. But number one, I'd put dimensional analysis. This is by far the most common way a chemist thinks on how to approach and attack a problem. Most, not all, but a large majority of the types of quantitative calculations we do in chemistry is taking a unit, right, some substance with a unit, and converting it into either that same substance with a different unit or a different substance with either the same or different units. So we're tend to taught, through, fourth, fifth, sixth grade, all that kind of stuff, to focus on the math, on the numbers, setting things up logistically as a mathematician would. That's not how a chemist thinks. So a lot of students struggle in general chemistry because we're trying to change how you think on solving problems. So we like to focus on the units. That's what dimensional analysis is. It's a problem-solving approach. By far the most superior problem-solving approach I've seen. If I find a better one, I'll teach that one. But I haven't found a better one yet, right? Where they focus on changing the units. So we look at the units. It's like doing a puzzle. I've been doing a lot of puzzles with my kids lately. You set the border up first, and you get the guidelines for it, and then everything else kind of falls into place. What we're going to do when we're solving problems now, we're going to look at the units. So I'm starting with here, with this substance and this unit. I want to get here to this substance and this unit. We call it a game plan, right? You can do it in your head or write it down. Well, how do I go from this unit to this unit? Can I do it in one step? Can I go directly in one step, like going from meters to kilometers? Or do I have to do it in a series of 2 or 3 or 4 or 5 or 6 steps, converting this unit to this unit and this unit to this unit with little like links in a chain? So convert that unit to this unit in step 1, and then step 2, that unit to that unit, and step 3, that unit to that unit, until you get to the unit you're after. And we'll complicate it more when we start changing species in later chapters. The way I look at it is, like taking a huge task that seems impossible, but breaking up into little sized chunks. But you do this if you're in, hard sales or something like that as well. And you got to get a certain number of clients by the end of the month. So in 1 month, they want 10 new clients. But you understand you're going to get a no factor of about 95% or worse, right? Depending on, if you're starting out especially. It's like, no, 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 no. Cold calls are hard, man. Your self-image takes a beating if you've ever done it. So you may find out after a while that your success factor is, if you call 10 people, you might get one person to listen to your pitch, right? And if you can pitch 10 people, you'll get one person to say yes, which means you have to call 100 people to get one client on average. And if you want 10 clients, you have to call 1,000 people. Just thinking about that, right? It's like, and if you wait till the last day, you're not going to call 1,000 people the last day of the month to hit your quota. You got to break it down and say, well, if I have 30 days, right? Take 1,000 divided by 30, and that's the number of calls I need to make per day. The problem is human nature procrastinates, so you wait till 8 o'clock at night and go, man, I can't make that number of calls. I can't make 20 calls or whatever it is, and at night. So you break it down into smaller size chunks. So I need to make, let's divide it by 3 and do a third of those calls before noon, a third of the calls between noon and 5, and a third of the calls between 5 and 9 at night, or 8 at night. And then you could break it down into making, hey, you know what? You can even break it down per hour. So to the point where if I make 3 calls per hour, that doesn't sound bad. Or even let's do one every 20 minutes. I can make 1 call in 20 minutes. And if you do that consistently, you can end up getting the clients you want, understanding you're going to miserably fail 90+% of the time. Do you see the thinking process? So you take something that seems here's this problem. You're like, I see so many students, they read a problem, go, bah, and they just shut their brain off. I can't even start it. I don't know what to do, blah, blah, blah. Dimensional analysis shows you how to break it down into little bite-sized steps. So if I say, can you convert meters to kilometers? Well, yeah. Can you convert kilometers to miles? Well, yeah. Can you convert miles to feet? Well, yeah. Okay. Well, we can put them all together and then do something that seemed impossible by doing a bunch of tiny little simplistic steps. And then you're there. That's what dimensional analysis fundamentally is. We can do this, guys. We can do some incredibly difficult problems very simply, one step at a time. How to eat an elephant. You heard that one? One bite at a time. So we're going to use what's called a unit line equation with a focus. You start with a species in a unit, and then I need to cancel that unit in the next step. So what I'll do is I'll have a unit in the numerator, and in the next step, I want that same unit in the denominator so that they cancel out. Right? And then I need to find a number that relates those two units, like the metric system we talked about, metric, 1,000 meters per kilometer. That is a quantitative relation between two different units. 2.54 centimeters equals 1 inch. That's a numeric value that relates centimeters to inches. If you have those values, then we can link these chains together. Okay, so let's talk about different types of conversion factors on the next board. So conversion factors are the key. All we're gonna do is do a unit line equation and connect a bunch of conversion factors together, converting one unit to another. We just need to know what those conversion factors are. So it's just a numeric relation. Oh, I just got really starving. You ever had that? You're just like, boom, I'm starving all of a sudden. Pizza, I want pizza. All right, so conversion factor is a numerical relation between two different units. And we can pick any two units we want. Sorry, I was petting my cat. Now I got cat hair all over my face. So for example, let's take for length centimeters, which is a metric or SI unit, to inches, an English unit. Well, there are 2.54 centimeters per inch. That's a numeric relation between those. 1,000 grams is 1 kilogram from the metric conversions, right? 4 quarters is $1 by the government has deemed it so. Right? But we can write these and set them up as a conversion factor. Let me show you how we do this. So if I'm going to set this up, I can set this up in two ways. Since they're equivalent to each other, I could say that is 2.54 centimeters per inch, right? So if I'm converting inches to centimeters, I can multiply a value in inches times that, and inches cancels out. So I just multiply it by 2.54. Or I could do it the other way. I could put the inch on top and put the 2.54 centimeters on the bottom. So if I'm converting centimeters to inches, I start with a number in centimeters and then divide by 2.54 centimeters per inch, right? So I could set it up either way depending if I'm going centimeters to inches or inches to centimeters. That's called a conversion factor, right? Some of these are exact, some of them are not. Right? So and this one happens to be exact, so it's an unlimited number of significant figures. Conversion factors that aren't exact, you have to account for those in your calculation when you're tracking uncertainty. So we want to use, as often as we can, exact conversion factors. And so if you go to my website, I kind of just hunted down a bunch of exact conversion factors for different things, length and volume and mass, temperature, all those kinds of things, energy units. So these are all exact by definition, right? So unlimited significant figures. The whole metric system is unlimited significant figures. So I would have this with you, download it in your phone or write it on a note card or something like that. Pause the video and write it down. Have those available to you. And really, that's almost all you need. You don't have to be Googling around looking for a bunch of stupid, weird conversion factors. Just use those and you'll be able to convert any unit to any other unit. It might take you another step or two using that, but at least you're using exact conversion factors so that they'll never limit your uncertainty. Well, let's set this up, this metric system conversion. I could set this up, let's use a different color, as 1,000 grams per 1 kilogram. You don't really need the 1 there, it's assumed. So if I'm converting kilograms to grams, right? I put my number in kilograms cancels out, and I multiply that number by 1,000. You've set up the framework with the units, and the numbers just fall into place. Or if I'm converting grams to kilograms, I flip it upside down. So if I start with grams, then I want to have grams on the bottom and kilograms on top, and we know there's 1,000 grams per kilogram, right? Or you could go 10 to the minus third kilograms per gram, but I like to avoid the negative exponents. And last but not least, you mentally do this. You mentally do dimensional analysis in your head, right? So if you have 8 quarters, if I say 8 quarters, you go $2 because you did the math in your head. I'm just showing you how to set it up. Right? So this is our relation. So we could set this up and say, hey, 4 quarters, I don't know what the abbreviation is for quarters, per dollar, right? So if I have $2, I convert dollars to quarters by canceling out dollars and multiplying it by 4. So 2 times 4 would be 8 quarters. Or if I have 8 quarters, I want to cancel out quarters, so I put the quarters on the bottom and the dollars on the top and go, there's 4 quarters per dollar. So you take the whatever it is, 8 quarters divided by 4 gives you $2. You've been doing this in your head since you were a little tyke. We're just, total fumble. I rolled a 1. We're just showing you how to officially do it. And that seems pretty simple, right? And then all we do is just do that over and over and over and over in a chain until we get the unit we want of the species that we want. Let's do some examples, some harder ones. And again, see if you can grab these exact conversion factors. These are like English to metric units, and this is from the metric system, the common ones I wanted you to memorize. But we could use on homework, I could use weirder metric prefixes because you got those available in your notes and probably in a textbook or something like that. But on exams, those are the ones that are fair game. Anything other than that, I would have to provide for you, at least in my class. Sometimes you'll get a conversion factor that's specific to a problem. So maybe you're doing some problem that is looking at the amount of, some little bananas, some substance in your blood, right? And it wants to measure, there's some conversion like the number of red blood cells per pint of blood. Right, that's a pretty specific conversion factor, and that would be provided for you. You're not going to look that up in a table in your book, in your chemistry textbook. So that would probably be given to you. There are this many red blood cells per pint of blood, and that would be given to you in the problem. Well, that's a conversion factor between number of red blood cells and volume of blood in pints. So you use that as a conversion factor. See, so you can get them either from that exact conversion factor table, metric units, or from the problem itself. Let's have some fun. All right, here's a starter problem for you. Pretty straightforward. So if Dr. Locks, that's me, your coach, weighs, remember weight and mass are technically different, but we're going to treat them as the same in this class. If Dr. Locks weighs 158 pounds, probably a little more because the gyms have been closed for so long. But anyway, let's say I'm 158 pounds on a good day. What is his mass in nanograms? So next time you go to the doctor's office, if they say weight, notice weight and height, if they ask you for it, they never specify the units. You can really mess with them good, right? So what you do while you're sitting in there waiting to go in, you got nothing better to do, just go, well, he didn't specify the units, so I can put whatever units I want and be a booger like them and don't put your units on it. So calculate your weight in nanograms and just write it in there, but don't put the units on there. And, you can so mess with them. You can get on there and be like, what's that mean? And they're all mad. And you're like, you don't weigh that. It's impossible. And 10 to the 13th, whatever. And you'll say, well, you didn't specify the units, so I did it in nanograms. Sue me. All right, here we go. Depends if you're my type of personality. All right, here we go. Or do your height in like centimeters or something. So you can have so much fun. A little ornery. So let's do our game plan here. If you can do your game plan in your head, great. I usually don't do them for 3, 4, 5 step problems. And once I start getting to 7, 8, 9 step problems, I'm like, I've lost myself. Once you get the game plan down, you're breaking. That's like when I talked about trying to get the 10 clients per month. You broke it down into bite-sized chunks. That was the game plan. How many calls do I need to do every 20 minutes? Boom, I can do this. So what's our starting point? All right, so we're starting here. Where's our ending point? It's like you're doing a vacation, right? The first question I always ask, at least my family's like, where do you want to go? Let's go here. And then we go, well, where are we starting from? And then you Google map it or whatever, and it shows you the destination. So if I want to go to Vegas, right, from here, I can plan that trip going, well, we're going to have to take some potty breaks with 4 kids in the car. So we'll stop at Barstow, and go potty there and, maybe get some more soda, some more caffeine to keep me awake. So so I couldn't do that in one step. I have to do it in 2 steps. Same thing here. You're like, I'm starting with this unit, going to that unit. I can't do that in one step, maybe 2 or 3 or 4. As we move along in chemistry, they'll get longer, not harder. Dimensional analysis takes away easy versus hard problems and just makes them shorter versus longer problems. None of them are technically hard. They're just longer. More steps, more chinks in the chain. Moving along. So we're starting with pounds. And we want to get to nanograms. This is an English unit, right? This is a metric or SI unit. They're both mass, so I'm good there. Everything's in mass there, and it's still Dr. Lax, it's still me, so I'm not changing into someone else. It gets more complicated for that. So let's look at our exact conversion. We're going English to metric, so let's look under our mass, right? So if you look under mass, I can go pounds to grams. I can't go pounds to nanograms, but I can go pounds to grams. That allows me to go from English to metric units. And once I'm in the metric unit, the base unit grams, I can go to any other metric prefix, right, using the metric conversion. So I can go, where's my purple pen? I've lost it, Captain. It's gone. I don't know where it went. So I can do this in 2 steps. Go pounds to grams, English to metric units using the exact conversion factor, and then grams to nanograms using metric prefixes. Let's set this up. So let's take our number, 158 pounds. Let's pop a conversion factor in there. You ready? So what was that number? 453.59237? Is that it? You'll memorize it after you use it 1,000 billion times. 453.59237. Yay! Now notice pounds are here, so I want pounds in the bottom here and grams on the top there. That allows me to cancel out pounds, right? That's the basis for dimensional analysis. So let's put our 453.59237 grams per pound. And again, you don't really need the one, it's assumed there. So check on step 1. Not so bad, right? That wasn't so bad. Just write the numbers in there. I might give that to you on an exam. I'm not going to make you memorize it. You'll memorize it, but I'll give it to you on an exam. English to metric conversions. Now let's do step 2. We got grams in the numerator, so we want grams in the denominator and nanograms in the numerator. The unit you are getting rid of in the denominator and the unit you want to get in the numerator. That allows me to go, hey, grams in the numerator, grams in the denominator, they cancel out. This I would expect you to memorize. So I know a gram is bigger than a nanogram, right? So I'm going to put a 1 in front of my gram. And nano's 9, so there's 1 times 10 to the 9th, or 1 billion nanograms per gram. You could have gone 1 times 10 to the minus 9th grams per nanogram. That works just as well. I just don't like it myself because I get mixed up with the negative exponent. So however that works for you. Gone, 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 gone. The only unit I have left is nanograms. Hey! This is a great way to check if you're doing things correct, because if your unit's wrong, you know your answer's wrong. So I've done a lot of problems where I was like, I'm not really sure what the question's asking, but I know I'm doing this unit, and I got to get to this one, and I'd play around with the conversion factors till I got the unit, and I'd get it right. I don't recommend doing it. I found my purple pen, I was sitting on it. That was awkward. So you can ideally you know what you're doing, but using dimensional analysis, sometimes if you're like you get a brain fart on a test, you can figure it out just by using dimensional analysis. So let's punch this out on our trusty calculators. So let's take 158. Whoop! The 5 did not appear. Clear that. 158 times 453.59237 equals times 1 second function e to the 9. Right? Make sure you get that scientific notation in there, the EE or the EXP button on there. This is exact. This is exact. That's 3 significant figures, isn't it? I'm going to stick that on my nose, I think. So since we're doing all multiplication division, we're limited to 3 significant figures. So I get 7.16679594446 times 10 to the 13th, right? Gets lots of digits in there. So let's get the first 3 significant digits, 7.16. Put the vertical dashed line there. Next to 67 times 10 to the 13th nanograms. And let's round it appropriately. That's bigger than 5, right? So that 6 is going to round up to a 7. So that goes to 7.17 times 10 to the 13th So that's what you can do next time you're at the doctor's office. They say, hey, what's your weight? I could write 7 times 10 to the 13th and just leave it at that. Oh, you'd have so much fun. Let's do a harder problem. Yes, harder problems. All right, let's raise up the difficulty level again. And again, it's not really harder, it's just maybe longer or something. But this one I would actually say is a little more challenging because we're using squared units. And this is I'm gonna introduce why I like, some people say, well, why do you use parentheses for your conversion factors? Why don't you use like the railroad tracks? Well, when you use the railroad track version, you can't square or cube your conversion factors. But if you use parentheses like I do, it's really easy to put a 2 or a 3 to square or cube a conversion factor. So this is going to show you where that comes into play. Ready? So let's take a look at the problem. Let's do our game plan. We'll write that out. What are we starting with? Right? Where do you want to go on vacation? Right? So when I read a problem, I usually look for what I'm solving for first. So a house is blah, blah, blah. So that's a statement. Oh, what's the area in square meters? So I want square meters. That's my destination. What am I starting with? So the house is 1,000. The numbers are relevant to me. Square feet. So I got to get from square feet, which is English units, and this is metric or SI units. So let's take a look on our exact conversion table and see if there's a feet to meters conversion that's exact. If not, we may have to do more than one step. So let's take a look here. Let's look under length. So the only one given is 1 inch is equal to 2.54 centimeters, and that's exact. Okay, so inch is the English unit. So I got to get from feet squared to inches squared. And once I'm in inches, then I can get to centimeters squared. And once I'm in centimeters squared, I can get to meters squared. Oh, so I can get to inches squared. You all know there's 12 inches per foot, right? And then we have to square the conversion factor. We got to do it twice. And once I'm in inches, I can use the exact conversion. 2.54 centimeters is 1 inch to get to centimeters squared. And once I'm in centimeters, I can get to the base unit of meters. Hey, so we're going to do this in 1, 2, 3. So this is a little bit, one step longer than the last problem, a little more challenging because we're using squared units. Let's do it, my friends. You ready? Pause it, see if you can do it and get what I get. Let's take our 1,950 square foot house. I think that's small. That's huge. That's a huge house for when I grew up, and people tended to have more kids. Now today, I think that's smaller than an average house sold today, and people probably have family sizes less than half. Commonly, when I was growing up, people had 6, 7, 8 kids. 5, 4 was really a small family. Today, if you have 4 like I do, people are like, man, you're weird. We'll take our 4. We had 4 kids in 6 years. We'd go to the park with our small army. People are like, whoa, I feel so sorry for you. We're like, yeah, we haven't slept for 8 years, but that's all right. But I love it. Love lots of kids. Houses, that's, our house is a little smaller than that. We're all crammed in here. It's all right. It's not the end of the world. It'd be nice to have a little more space, though. Here we go. Let's convert this. Now, really, I need to do this twice. Now, I'm going to do this 2 times. And then show you how to condense it. So we technically would have to go feet to inches 2 times, right? So feet times feet is feet. See how we did that twice? Well, let's condense that and just do it this way. Instead of writing it 2 times, let's just go 12 inches per 1 foot twice. See why the parentheses are nice? Okay. So I reckon, so instead of railroad tracks, I prefer parentheses. Not right or wrong, just easier. So check. Now let's do the centimeters and inches conversion. So we want inches on the bottom, centimeters on the top. This tells me there's 2.54 centimeters per inch, right? But that's not squared. It's not 2.54 centimeters squared per inch squared. It's 2.54 centimeters per inch. I need to do that twice like that, right? So feet squared cancels out feet squared. Inches squared cancels out inches squared. So you square the 12, the inches, the 1, and the feet. You square the 2.54, the centimeters, the 1, and the inches. All numbers and units inside the parentheses gets squared in the process. Check. And then we want to go from centimeters to meters. There's 100 centimeters per meter, right? And we need to square it so that the centimeters squared cancels out, leaving me with meters squared. This is exact. This is exact. This is exact. That is 3 significant figures. Zero, a trailing 0 with no decimal point is not significant. So we get 3 significant digits. So pop that out on your calculator. See what you get. I get 181.16. $181.16. Good to 3 sig figs. It's closer to 181, so we do not round it up. There you go. Let's do one more example where we do numerator and denominator units, like a rate or a speed, and convert them both simultaneously. We'll do it quick, though. I'm not going to do it slow. We're going to do it quick. You ready to attack this one? So let's say a sprinter runs the 100-meter dash, and we'll make that 3 significant digits on the 100 meters. In 9.6 seconds, that's booking along pretty fast. I think the fastest I ever did it was 10.55. Wind aided. This person would just toast me. And I was ranked top 10 in the state, too. Not in the 100, though, in the 400. What is their speed in miles per hour? Because we think of that, we don't have a concept how fast they're going, but we would in miles per hour. I mean, probably slower than a cheetah. Cheetah around 65, 70 miles per hour. I don't think people could run that fast. So if you get a number of 120 miles per hour, that wouldn't make sense. So let's go through this. Let's set it up. So we have distance over time. So our distance is 100 meters. So let's take our 100 meters over our time, 9.6 seconds. That's our starting point. Notice we have the numerator units and denominator units. So we're going to do them both. Rather than going meters to miles separately and then seconds to hours separately, we'll just do them at the same time, right? So we're going to go from seconds to hours. Well, actually seconds to minutes to hours, right, for our time units. And then we're going to go from, what's our meters? Now remember, there's the 2.54 centimeters per inch. So let's go to centimeters and then to inches, inches to feet, and then feet to miles. So these are the 2 separate ones we're doing, but we'll do it all in one chain. Okay? So let's convert. You can do meters to miles first or seconds. Let's do seconds first. So 60 seconds per hour, correct? Seconds in the denominator goes in the numerator. Let's get rid of hours. Wait a minute. Oh, that's supposed to be minutes. My units didn't work out there. 60 seconds per hour. 60 seconds per minute. There we go. And then 60 minutes per hour. So I have successfully gotten rid of seconds and minutes. So I have hours in the denominator, right? Miles per hour. So now I just got to get meters to miles. So let's put meters on the bottom. Let's go to centimeters. For every meter, there's 100 centimeters. See that? There are 2.54 centimeters per inch, says our trusty table. That's exact. And then there are 12 inches per foot, right? And then hopefully you know there's 5, that's supposed to be a 5,280 feet per mile. So meters in the numerator cancels out meters in the denominator, centimeters, inches, feet. We have miles per hour. Hey, I'm going to pause this. You calculate it, see what your sig figs are. Did you get my answer? 23 miles an hour? Right, so we converted everything. That's 3 sig figs, that's 2. Exact. Not sure if that's exact, but it'd be 3 anyway, and the 9.6 limits us to 2. Bad clock. So I get 23.30 miles per hour, closer to 23 than 24, rounds to 23. That would be their average speed, obviously. That's not their speed coming out the block. That's cruising. That's about as fast as humans can run. You can do this. Master dimensional analysis.